Okay. So I'm looking here and realizing this is just a little bit on the dark side. So let me see if I can get this a little brighter. I don't know if that's helping or if that's just confusing your monitor, but let's give it a try. Fingers crossed I'm getting some new lighting today and this will all be fixed. This is Math 60, 4.2 page 3 or trois. There we go. And we're continuing on with more exciting inequalities. So, what's exciting about this? Well, we don't know yet. Let's go ahead and see. So, as usual, I have left myself almost no room whatsoever to actually simplify these. So, I'm going to have to reach over here to my handy dandy, not so handy, almost dandy. Woohoo! Blank piece of paper, and I'll go ahead and post the links, the scan of this as well. I'm going to take my two graphs, and again, I'll number them just to make it easier to follow. I'm going to have my first inequality is 2x minus 3 is greater than 1. And my second inequality is negative 3x plus 1 is greater than negative 2. And so again, if I were a computer, I'd be able to look at these and graph them very easily. And then with the graphs, we could see the overlap. Since again, this is an and problem once again, so we're looking for the intersection. But I'm not a computer, so I'm going to have to work on coming up with equivalent inequalities that will help me see what's really going on here. For example, here I'm going to try to isolate x, so I will add 3 to both sides. 2x is greater than 4. Hopefully this is becoming really straightforward and almost like something you could do in your sleep. Divide both sides by 2. And I get x is greater than 2. So not too hard to graph. Over here on number 2, I see that I've got a plus 1, so I'm going to subtract 1. Negative 3x is greater than negative 3. Dun, dun, dun. Now, you're either going to have to go to extraordinary lengths to make sure this is not negative, by which I mean you're going to have to move the x's over onto the right-hand side, which you are absolutely welcome to do. But because I'm feeling dangerous today, I'm going to go ahead and divide by negative 3. I know. They said don't cross the streams, don't divide by a negative number. It's okay. We can handle it because I have, and I know you guys are as excited as I am, I have a yellow highlighter. Pretty much, you don't have to fear anything in the universe if you have a yellow highlighter. Let's be honest, right? So when I divide, remember, I can't spell and talk at the same time, so I'll be right back. Dividing by a negative flips the inequality. Equality. There we go. Thank you, phonics. Ooh, you can't quite see that. There we go. Okay, so my inequality was a greater than. It will now be a less than. So let's see. Over on the left, I get x is less than 1. Now, lizard brain may start to panic because I have just set up a situation where I say x has to be greater than 2 and x also has to be less than 1. Do not let the lizard panic. Number 1, never let the lizard panic. It's all going to figure out. It's all going to work out. I'm never going to give you a problem you cannot solve. So just take a deep breath and we're going to say, okay, let's figure out what to do. You've told us that number 1, x has to be greater than 2. And number 2, x has to be less than 1. This seems pretty impossible, but let's go ahead and look at what I'm going to actually say. Here's 1. Here's 2. 1, 2, 1, 2. So x is greater than 2. I'm going to put a parenthesis on the 2 and go bigger. X is less than 1, parenthesis on the 1, go smaller. And in case you guys are curious, this, because I had some questions today, I'm going to go ahead and write just this graph would be written as from 2 to infinity, no beyond. That was, Disney was making that up. There is no beyond. This one would be from negative infinity to 1. So the question is, we've got up here, we've got an intersection, which is an overlap. So what is the overlap? And the answer is there is no overlap. So following up with some other things we've talked about. Oh, never mind. I'll skip it for right now. We'll come back to it, I'm sure. There is no overlap, so there's no solution. Bam, that's it. You're done. The problem can't be solved. And what this really means is we did actually solve it. It means that someone was looking for a solution set that makes both of these inequalities true. And what you could say to them is, I'm sorry, there are no numbers that would satisfy both. If you want one or the other, I'm happy to help you, but both is just not going to happen. Okay, so then we feel this is exciting because, there's no solution. Woohoo. It's a brand new world where we could just say, I refuse to answer this question, and that could be the right answer. I think that's awesome. And then just when we're feeling really great about the world, we notice this is a union. This is an or. So what we're looking at is we want to look at all the values that satisfy this inequality and then add those to the values that will combine those with the values that will satisfy this inequality and consider all of them. So remember, again, this is like when we were talking in class and I said, or perhaps I haven't said it yet. I'm getting forgetful about the things that we've talked about, the things that I just imagine we've talked about. But I said, would you like to eat some ice cream, or would you like to eat a raw Tasmanian devil who's biting you? And the answer from a mathematician would be yes, I would like some ice cream. So as long as one of them is satisfied, that's sufficient. Okay, that was one of the weirder things. Love to see the transcript on this one. So again, just to make it easier, I'm going to number these two so that you can follow along. I think I may have enough room right here. So I'm going to go ahead and work on number 1 right here. 7 plus 2x is less than -1. Subtract 7 from both sides. 2x is less than -8. Divide both sides by 2. And I get x is less than -4. Does that make sense? Hopefully it does. Number 2, I've got 13 minus 5x. You can't quite see me, so let me move that a little bit closer to the center. 13 minus 5x is less than or equal to 3. Subtract 13 from both sides. And yet again, dun, dun, dun! Almost if somebody wanted you to have to deal with this. Ooh, that was exciting. I almost left that off. There's a -5x in this one. So I'm going to divide because I'm not scared of this anymore. I'm lying. I really don't like it, but you can't win them all. But remember, even if you're scared in the world, if you've got a yellow highlighter, nothing can hurt you. For long. Less than or equal to becomes greater than or equal to because, again, I'm dividing by a negative, multiplying or dividing by a negative in an inequality just flips the inequality around. That's all that happens. So I've got x is greater than or equal to, I think, 2. Okay, so sorry about that. Graph number 1 is going to be x is less than -4. 2x is greater than or equal to 2. Now, if this had been an and problem, we'd be in the exact same position we were in up here. There's no overlap. Because when we look at these two, x is, sorry, let me make this mirrors. They're so fun. X is less than -4, starts at -4 and goes all the way to the left. And then -4 would be in both of these places. And this is 2. X is greater than or equal to 2 goes this way. Now, because this is a union, not an intersection, a union is like if you imagine like a civil union or a union of laborers, we're going to bring everyone together. And so instead of looking for overlap, we're looking to bring everyone in. So x is less than -4, union x is greater than or equal to 2 is going to look like all of these points from the first graph and all of these points. This is almost like a Happy Sesame Street skit here. Let's bring all the furry monsters together. All of the points from the second one. So everybody gets to join the fun. And so how do you write this? Well, there's a key here in the u. We're going to go from -infinity to -4. This is a parenthesis because this is a strict less than. Then I'm going to skip all of this stuff. So I'm going to take a union that helps me jump over all the points in the middle. And I'm going to start up against at 2 and go all the way to infinity. Bam. Okay. Woohoo. Only one more page. I'll see you in just a couple minutes. Woohoo.